Hi everyone, it's Coach Fred here, and today we're going to be talking about triangles some more. So you're in your 8-3 notes, and it's actually called Pythagorean Inequalities. But for now, what I'd like us to look at is a D on your note sheet. Can a triangle be formed with side lengths 5, 5, and 10? And it says explain your reasoning. Now last week we investigated this. This is when we learned what had to be true in order for side lengths to exist. So I actually took some segments here. I made one that was 5, another one that was 5 here. Oops. And I'm moving it up here. And then one that was 10. And you might remember that we said that, here, let me try this. If I move this down, that in order for these to actually create a triangle, you can see that it doesn't quite meet the edge of the triangle. What had to be true was that 5 plus 5 had to be greater than 10. And that had to be true for all different ways you could pair up the sides. And since 5 plus 5 is not greater than 10, a triangle cannot exist with these sides. Okay, but now let's pretend we have a triangle, 12, 16, 20. And we see that a triangle does exist because 12 plus 16 is greater than 20. 20 plus 16 is greater than 12, and 12 plus 20 is greater than 16. So we know all those are true. A triangle does exist. How do we classify the triangle as either obtuse, right, or acute? Well, in looking at this triangle, I happen to notice, and maybe you do, I happen to notice that these could be a 3, 4, 5 Pythagorean triple. And if I multiply each of them by 4, then it is I can prove that it's a Pythagorean triple. Well, remember, Pythagorean triples only exist when a squared plus b squared equals c squared, when c is the longest side. So one way to be able to prove that something is a right triangle would be for me to see if 12 squared plus 16 squared equaled 20 squared. And if that were true, then it would be a right triangle. Now, in this case, if it's a Pythagorean triple, we also can say that it is a right triangle. So let's look at this next one. Is a triangle with side lengths 7, 24, 25 obtuse, right, or acute? Well, if I didn't recognize the pattern, I could see if 7 squared plus 24 squared equaled 25 squared. But since I know you guys are working really hard to learn your Pythagorean triples, this is a Pythagorean triple, which means that it would have to come from a right triangle. Okay, well that helps us with a right triangle, but what about obtuse or acute? So let's take a look. First of all, let's go back to this idea of right triangle. As long as c is the longest side, if c squared equals a squared plus b squared, then the triangle is right. So we could test it. But again, we're back to obtuse and acute. Well, there's two cases. Okay, we can get the case where c is still the longest side, but c squared is greater than a squared plus b squared. So c squared, I'd like to say, is bigger than a squared plus b squared. When it's bigger, then it's obtuse. This would form an obtuse triangle. All right, now if we do the same thing and c squared is less than a squared plus b squared, so c squared is small and cute, like Coach Fred, then it would be an acute triangle. All right, so let's test it out. If a triangle can be formed, so we have to always test that first, classify the triangle as acute, obtuse, or right. Okay, so first we have to show if the three numbers form a triangle. All right, so 5 plus 12 is greater than 13. 13 plus 12 is greater than 5, and 13 plus 5 is greater than 12. So yes, a triangle exists. Then I would do 5 squared plus 12 squared blank c squared, 13 squared. I want to see what the relationship is. Well, you might already say, Coach Fred, why are you even doing that? It is a Pythagorean triple, so it is going to be equal, which means that it's a right triangle. Okay, so we apply the inequality, and that's how I apply the inequality. I don't put anything in this spot. I leave it as a blank so I can fill it in. All right, I go to the next one. First, I show if the two numbers form a triangle. Well, 6 plus 5 is not greater than 12, so no triangle exists. All right, I go to the next one. I show if the three numbers form a triangle. 7 plus 8 is greater than 9. 9 plus 8 is also greater than 7, and 9 plus 7 is greater than 8. So yes, a triangle exists. So now I apply the inequalities. I let C be the longest side, and I do 7 squared plus 8 squared blank C squared. All right, so I get 9 squared. That would be 9. 9 squared. All right, 49 plus 64 and 81. All right, so 49 and 64 is 103. So 103 is greater than 81. So C squared is small and cute. And so it is a cute triangle. All right, so now the video is going to ask you to try one on your own, okay? All right, so just to recap. If C squared equals A squared plus B squared, and C is always going to be the longest side, then it would be a right triangle. If C squared is greater than A squared plus B squared, so C is big and fat, okay, it would be an obtuse triangle. And if C squared is less than A squared plus B squared, it would be an acute triangle. All right, guys, hopefully that's a nice, quick, easy idea for you guys to understand. I do want you to do the try nows. If a triangle is formed having the side lengths below, is it a right triangle? Love to see what you could do with that one. All right, we'll be practicing this tomorrow in class. Have a great day.